Hello again. Let's look at this problem here where my cursor is. D by dx of the natural log of the secant of x. Notice we've got the composition of functions, namely the natural log composed secant. So this is sort of begging for the chain rule. And that's what we'll have to do, is use the chain rule. So we let u go down here. We let u equal the secant of x. So replace the secant of x with u. And do the chain rule, you'll get d by du of the natural log of u times d by dx of the original u term, which is sec x. Remember, u equals the secant of x. So by the chain rule, we have all this stuff here. Okay, but now guys, remember, the derivative with respect to u of the natural log of u is 1 over u. Remember I told, if I didn't tell you this before, I should have. The derivative of the natural log with respect to that variable is just 1 over that variable. I didn't prove that at all. I'm just having you take that on faith, so to speak. When you get to advanced cal, you'll get to prove that. But just take my word for it that the derivative of the natural log of u is 1 over u, and the derivative of the secant is the secant tan. I did prove that, but I'm pretty sure I did. It's been a while ago. It's been videos ago. But anyway, let me scoot this 1 over u down here to the next line so it'll look better. And let me scoot this whole thing down here if it will let me. Times past it gave me trouble. Okay, so we have, and sorry guys, I'm trying to get this spaced correctly. I'll get it right. So finally, now just recapping, sorry I threw you off track there. We let u equal the secant of x. We do d by dx of the ln of secant of x is d by du of the ln of u, chain rule here, times d by dx of the secant of x, also coming from the chain rule. And then now keep in mind, again, as we said earlier, d by du of the natural log of u is 1 over u. And now the derivative of the secant is the secant tan, or sec tan. We have proven that with limits before, but you can just take my word for it if you'd rather. Okay, so now guys, all we're really saying here, this is just going to be sec x tan x over u. So we have sec x times tan x over u, but u is the secant of x. Remember, we need to replace u back for what it is in terms of x. U is the secant of x from the very beginning. Okay, but hey guys, lo and behold, you see this secant term here and this secant term here, they divide away, and you're just left with the tan of x. Okay. Oh, that's kind of cool. So the derivative of the natural log of the secant of x is the tan of x. Okay. So there's that. Now, here's something you have to be careful. That was actually a fairly nice problem. This one, please be very careful. Go ahead. See where I've got this highlighted? What I'm going to do next is not the natural log of x cubed. I'm going to cube the natural log of x. That is not the same thing as this guy down here. So first, go back up here to where my cursor is. D by dx of the cube of the natural log. Not the natural log of x cubed, okay? That's not the same thing. So we're cubing the whole thing. We're taking the natural log of x first, and then we're cubing that result after the fact. So d by dx of ln x entity cubed. We do chain rule, we let u equal ln x, and I should have specified that real bad here, where u equals ln x. Okay, so that's d by du of u cubed times d by dx of ln x, where my u is ln x. Let me space there. And so we have this by the chain rule. And then now guys, if you derivate this d by du of u cubed, that's just going to be 3u squared. D by dx of ln x is 1 over x, so we have 3u squared times 1 over x. That's just 3u squared over x. I just go ahead and cut to the chase. And then I replace u with what he is. He's the ln of x, but you got to have these parentheses, you need all of them. You can't leave off a single parenthetical entity up here. It's not a matter of taste. You have no choice. You must have all these parentheses. You're squaring the whole ln. You're doing the natural log of that number first, and then after that, after the fact, you're squaring it. And then, well, after that, you would multiply it by 3. But anyway, the point is, you're taking x, which is a positive number, by the way. You're taking its natural log. You'll get some number. You'll square that number. Then you'll take that and multiply it by 3. In that order. And that order does matter. Okay? And the last thing you'll do is divide by x. But that's kind of obvious. So Now, I'll leave it for you to do this one, where the 4 is here, okay? Now, let me just put a word of warning, danger. Now, what if we had the ln of x cubed? The ln of x cubed is not the same thing as this guy up here. This is a very different thing here. The ln of x cubed for a positive x is 3 ln x. But the ln of x cubed is not the cube of the ln. The ln of x cubed is actually 3 times ln. Okay? Just watch out for that. This is a L, this is an N. Please watch out, okay? Danger, sine cubed of x. Now, this is I won't say unfortunate, but it actually makes sense. No, it ain't. It's not unfortunate. The sine cubed of x is as it ought to be. It's the cube of the sine function. You take x, you take its sine, you get something in return, and then you take that output you just got and cube it after the fact. You do the sine first and the cubing next, in that order. However, now this guy is very different. This time you cube first and then you sine after you cube. Very different. You're not going to get the same result in general, okay? Watch out. And now here's the bad news as far as consistency goes. It's not really bad news, it's just a headache, it's just a nuisance. You know how like sine squared really does mean the square of the sine, and sine cubed really does mean the cube of the sine? -1 is the only number where we violate that idea, and we don't let it hold true. Unfortunately, we let sine -1 of x be the inverse of the sine and not the reciprocal, as we feel like it ought to be. You know, if it went like the 3 went, this feels like it ought to be the reciprocal, and really it ought to be. It's just the mathematicians from hundreds of years ago, they laid down the law and decided they wanted this to stand for the arc sine, or the inverse of the sine, and not the reciprocal of the sine. Really, to stay consistent with this, it would need to be the reciprocal, but unfortunately, we break the rule and we abuse notation. It is unfortunate, but it's an annoyance you just have to get used to. It's just an old tradition. This is arc sine. It feels like it ought to be the cosecant. Well, they just don't let it, okay? You'll just have to break the rule. -1, you'll just have to live with it. It's the arc sine. It is not the cosecant, and I'm sorry about that. So this is not the reciprocal, even though, you know, it just is what it is. You'll just have to live with that definition. Yeah, and again, the arc sine is not 1 over the sine of x, which is the cosecant, which is what really, to be consistent, if they had really been consistent with their notation, it would be this, but it's not. They decided to break it away and let it mean something else. The arc sine is, now what is it though? They demanded that it be the inverse of the sine and not the reciprocal. So the arc sine, we call it the inverse sine or the arc sine, and ditto for the other trig functions. We also commit the same breakaway for tan and cosine, for inverse tan, inverse cosine. We do the same thing. -1 means the same thing. The same unfortunate thing happens for those functions as well, for all the other trig functions. Sorry about that. It just is what it is. The same thing happens for the hyperbolic functions as well. And again, it just is what it is. But let's move on. Now, d by dx of the sine of x. Guys, we're going to do the chain rule. We're going to let u equal the sine of x, this inside guy here. So by the chain rule, we do d by du of the sine of u, where u is that interior sine of x, then times d by dx of the u term, which is sine x. And well, d by du of sine u is cos u, and d by dx of sine x is no surprise, cos x. But now, guys, remember, you got to replace u with its original, with what it was in terms of x. U is sine of x, so you have to replace this u right here with this sine of x right here. So we have the cosine of the sine of x times the cosine of just x. Here we're doing, what's going on here is we're taking a number x, we're taking his sine, and then we're getting an output, and then we're taking that output and putting him as input in the cosine, and we put that output from the sine into the cosine and get another output. The output of the sine is the input of the cosine. That's what's going on here. Okay, and you can keep going with this. You can roll. Like, you can do the derivative of the sine of the sine of the sine of x. And when I say derivative, I naturally mean with respect to x. You're going to have to do two things here. You've got an interior of an interior. You've got the intermediate interior, which is sine of x, and you've got the innermost, which is just the sine of x. Let's let v as in Veronica be equal to the sine of x, and let u be the sine of the sine of x. U is in up. Let that be the sine of the sine of x. Okay. Now we're going to do the chain rule. We're going to do two applications of it. Okay. Now here's what we're going to do. Okay. First, we just do. Let's just do u. Well, let's see. What do I do here? I do d by du of the sine of u, okay, which is fine, and I do d by dv of the sine of v, which is fine, times, I had to skip a line, d by dx of the sine of x. Okay, and this is just the chain rule. Guys, you just start from the outermost. Let me explain what I did here. I started from the outermost and went to the innermost. Like, this is my outermost sine. Here we're just doing the sine of this other stuff, and this other stuff is called u. Remember, u is the sine of the sine. That's this other stuff right here. So by the chain rule, I do the d by du of the sine of u. That's the outermost. And then times d by dv of the sine of v. Now, guys, the v is just this sine x right here, where my cursor is. And then times d by dx of sine x. Okay, now that's taking care of business. That's when the buck stops. Okay, so x is just x. So remember, x is just x. V is this sine of x here. U is the sine of the sine of x. So again, x is just naturally x himself. V is the sine of x. U is the sine of the sine of x. I'm starting right and going left. Okay, so v is the sine of x, u is the sine of the sine of x. So we do outermost here, the intermediate here, and then the innermost here. When you've gone to x itself, you've gone as far inside as you can go. Okay, so what we have is d by du of sine u is cos u, d by dv of sine v is cos v, d by dx of sine x is cos x. So we have cos u, cos v, cos x. But remember, we got to u and v had to be replaced with what they originally were from the beginning. So we replace u with what he was. So we have the cosine of u, but u is the sine of the sine of x times the cosine of v, but v is just the sine of x times the cosine of x, and there's nothing to do with that guy. You know, he's already in good form. All right, so there's that. And notice you can do this a buku of times. This is 3 times. You can do 4, 5, a billion if you really wanted to. It would take a long time, but anyway. Now, just to show it off, I do 4 iterations. 1, 2, 3, 4. Now, starting with this second guy here, the sine of the sine of the sine, I'm going to let that be u. The sine of the sine, this time I'm going to let that be v as in Veronica. This guy, or the sine of the sine of x is v as in Veronica. And then just the plain old sine of x, well, that's going to be w as in William. So that's all that stuff right here. And then x himself, of course, is as far in as you can go. All right. So there's all that. And I had to skip down here. I don't like skipping pages. I don't like skipping lines, to be honest. But that's just not very stylish. Let me move that down there. And now, guys, here we go. So this outermost sine, so we do d by du of the outermost sine of u. The sine of the sine of the sine of x is u. So we do d by du of sine u times d by dv of the sine of v, where v is these two innermost sines, or So the sine of the sine, or the almost innermost sine of the innermost sine. So the sine, this guy, all this stuff right here is v. The sine of the sine of x. That's v. So d by dv is sine v times d by dw is sine w. Now, guys, w is just the sine of x. Okay, just this guy right here, just this innermost sine. And then times the nitty gritty, d by dx of the sine of x. That's as far as you, we're here at x himself. You can't go further in than that. You always want to end up at this x guy here. Okay. Now you've actually, we go in and do it. It's actually easy on account of the fact that we have substituted. Now d by du of sine u is cosine u. D by dv of sine v is cosine v. D by dw of sine w is cosine w. D by dx of sine x is cosine x. So we have cosine u times cosine v times cosine w times cosine x. But we got to go back and replace the three letters u, v, and w with what they are in terms of x. Down here, remember, from the get-go, u equals the sine of the sine of the sine of x. Excuse me. U equals the sine of the sine of the sine of x. B is the sine of the sine of x, and w is just the sine of x. So we do the cosine of the u guy times the cosine of the v guy times the cosine of the w times the cosine of x himself. And so there's all that. Okay. Yeah, you can keep going. That's 4 iterations because we have 4. What I mean by that is we have 4 sines. Sine of the sine of the sine of the sine. You could do 4 billion iterations, or however many you wanted to do. It would take a while, suffice it to say, right? But anyway, I'm showing off that this is the chain rule generalized. This is, you work your way outside in. Truth be told, you could do the converse and work your way inside out. That's fine. I like to start outside, but it's up to you, okay? Some students might like to start with x and then let w be sine x, then let v as in Veronica be the sine of x, and then let u as in upward be the sine of the sine of the sine of x, okay? Notice that if you have 4 iterations, u is going to have 3 iterations, v is going to have 2 iterations, and w is going to have 1 iteration. And guys, notice something else. And when I say it, I mean the original thing that we're taking the derivative of, the function that we're taking the derivative of in the first place. If it has 4 iterations, aka 4 sine compositions, each one inside the other. So there's 1, 2, 3, 4 here. Then there'll be 1, 2, 3 in u. There'll be 1, 2 in v, and there'll be just 1 in w. U, v, and w are not sacred. They're just letters that I chose because that's what I'm used to. You can choose them in different ways. You could let w, your w could stand for my u. Just be consistent, okay? And another thing, now notice in my particular example, I had 4 iterations of the sine. What if you had 10 of these iterations? What if you had another problem where you had the sine of the sine of the sine, you did it 10 times instead of 4 times like I did here? What if you had 10 of these instead of just 4 of these? Then you would be better off to ditch the whole UVW notation, just throw it out the window. And what I would do if I were you is I would use, let's just say, it doesn't matter, you can pick whatever letter, let's just say P1, or no, let's do P9. Let's say I've got 10 of these iterations here, then I would start out with P9. P9 would be 9 iterations of the sine. I would have the sine of the sine of the sine of the sine of the sine 9 times of x, and then P8 would be 8 of those. That would come next. Then P7 would be 7 of those, and P6 would be 6 of those. I'd keep going on down the line until I got to P1. And P1 would just be the sine of x, which is naturally just 1 iteration. It's just easier to use subscript. And when I say P1, I mean P subscript 1. When I say P9, I mean P subscript 9. You use little subscripts. That'll be all for this video. Thank you. Bye-bye.